Hello everyone. In this video, let us see Rayleigh power method. It's an iterative method to determine numerically largest eigenvalue and the corresponding eigenvector of a square matrix. Basically, square matrices 2 cross 2, 3 cross 3 and all those things. And we'll be having more than one eigenvalue. Here we are finding the dominant eigenvalue. So this is your given question. Basically, they'll give the initial eigenvector. Okay. So if they don't give the initial eigenvector, then in that case, we'll assume any one of these, that is 1, 0, 0, 0, 1, 0, 0, 0, 1 or 1, 1, 1. It's a column matrix. So in this problem, they didn't give any initial value. So I'm taking this as x power 0. You can see that initial one. Since it's a column vector, I've written the transpose. Okay, now we are going to multiply A, the given question, with x power 0. So it is a simple multiplication. 25 into 1. Because it's a 3 cross 3 matrix, that's a 3 cross 1. So resultant will be a 3 cross 1. So 25 into 1 plus 1 into 0 plus 2 into 0, which is nothing but 25. Again 1 into 1 plus 3 0 plus 0 0. So 1 into 1 is 1. And the last row 2 into 1, that is last row, and then one column, right? 2 into 1 plus 0 into 0 plus minus 4 into 0, which is 2. If you see, 25 is the highest value, magnitude. I am taking that out and dividing all the values by 25. So that 1, then 1 by 25, 2 by 25. So you can write this in terms of decimals also. So 1 by 25 is nothing but 0.04. 2 by 25 is 0.08. Now if you see, largest eigenvalue is 25 for the first iteration. Now second iteration, Ax power 1. So x power 1 is the value that you got in the previous iteration. So we'll write A as it is, and x power 1 is 1, what you got in the previous iteration, 1, 0.04 and 0.08. Again matrix multiplication. So better use a calculator and save the matrix A. So every time you have to change only this. If you do by the normal method, 25 into 1 plus 1 into 0.04 plus 2 into 0.08, the normal matrix multiplication way, of course it takes time and it's tough for you, right? No one is going to give you the step marks for the calculation over there. So you can use the calculator to save time. And if you simplify the first value, and again you can see this is the highest value, and what you can do, you can take the highest value outside. Okay, so if I divide all the values by the highest value, we will get, always after taking the highest value, the first value will become 1. It's not 25.12, it's 25.2. If you take 25.2 common, first one 1, second one 1.12 by 25.2, which is 0.04. Then 1.68 by 25.2, which is 0.07. So now if you see, highest eigenvalue is 25.12. Initially it was 25, now it's 25.12. So we'll repeat the iteration process until and unless we get the same eigenvalue and the eigenvector. So again I'm writing the given question, and x2 is what you got from the previous iteration. Please be careful here, checking should be done step by step, because if you have done iteration mistake in say first iteration, then you have to change all the iteration values. So better calculate twice, okay, and then go for the next iteration. Now if you see, highest value is 25.18 and the remaining value 1.12 divided by 25.18 will be 0.04. 1.72 divided by 25.18 will be 0.07. And if you see how many times I have to do the iteration, until and unless I get two decimals same or the same eigenvector. If you see first one, it was 25, and one 0.04, 0.08, and second iteration 25.2, and if you see the eigenvectors are same. And in the third iteration, it is 25.18, which is somewhat closer to the previous one. And so we will stop the iteration and we can conclude that the largest eigenvalues 25.18 and the corresponding eigenvector is 1, 0.04, 0.07. Usually most of the problems you will repeat the iteration at least 6 times to get precisely the two decimals same. Here in this problem we got the exact decimal. So finally you can conclude it when you decide that I'm going to stop the iteration, then you can conclude like this. So practice more problems and try to find out for your calculator version how to multiply two matrices. Thank you.